.NET back when it was Windows IIS and Windows NT4. So I've been doing web development on Microsoft for a long time, 25 years. I'm a Microsoft MVP. Thank you, Microsoft. That's kind of cool. I run the London .NET user group in London where I live, which has been going for a long time now. I'm a systems architect in London at a company called Spotlight, and my website is here, dylanbeattie.net, which is where I post articles and links to code and all kinds of things like that. So a couple of bits. First, all the stuff we're doing today, the slides and code are already online. I uploaded them all this morning. So if you go to github.com/dylanbeattie.netby, you'll find all the code samples, all the slides and stuff. So if there's anything you want to go back and have another look at and see how it worked, please go take a look on there. As you probably worked out, ja nie говорю по-русски. Я не размаю по-белорусски albo. So I will be doing my talk in English. If I'm going too fast or someone doesn't understand anything, just hold your hand and wave like this, and I'll go back and I'll repeat it or slow something down. Or I'm here all day. If there's anything you want to talk about, come and find me later and we can go over it. Okay? So we're going to talk about REST. We're going to talk about representational state architecture. Now, the reason why I started doing this talk is lots of people say, we have a REST API. You talk to a vendor or a supplier and you're like, we need to integrate with your system. And they say, oh, it's fine, we have this REST API. And you go and you look at it and it's not actually REST. It's just a thing where you can run functions over the web and get back some XML. And that's all it does. And everything's a post and everything is XML. And there's a lot of confusion around what REST actually is and where it came from and what it's for. Now, there's a lot of stuff in computers like cloud and DevOps where no one actually has any idea what it really means because it's just these words that crop up. But the nice thing about REST is it was invented by one person, this guy, Roy Fielding, who is now the principal scientist at Adobe. Roy worked on Apache, and he was at CERN when Tim Berners-Lee was building the first web protocols. And he actually wrote, his PhD thesis, his doctorate, was called Architectural Styles and the Design of Network-Based Software Architecture. This kind of defines what REST is and what REST is not. So we have a reference we can go back to answer questions about, is something RESTful or not? Now, there's a couple of interesting things I want to highlight, which Roy himself actually said about REST and architecture. When given a name, a coordinated set of architectural constraints becomes an architectural style. Now, this is the first really important thing. REST is not a framework or a language or a plugin, or REST isn't something you can download. REST is not something that you can install. It's not, it's not a tool. It's a set of constraints. It's a set of rules that say if you solve your problems in a certain way, the thing you will end up with is a RESTful system. So what we're going to do today is to walk through some common problems that you'll encounter when you're designing APIs and show you how REST says, what are the RESTful patterns that will let you solve those problems. There's something else he says which is very important. REST is software design on a scale of decades. Every detail is intended to promote software longevity and independent evolution. Many of the constraints are directly opposed to short-term efficiency. Now, the reason this is important is because a lot of the time in software development, we're not working on systems that are going to run for 10 or 15 or 20 years. We're building prototypes. We're doing MVP, version 1, mobile app, Now, sometimes REST is not going to be the right answer for the problem you're trying to solve. Only you can answer that. I'm going to tell you today how you can do RESTful things, and I'm going to tell you why. I can't tell you when. Only you can decide when REST is the right system for you or the right approach for you. But you can't do that unless you kind of understand what it is and you can talk to other people about REST and how it works and how it fits into all the other things we're working on. So, as I said, REST is a coordinated set of architectural constraints. What are they? The first constraint is a thing called client-server. REST is about building systems that run on a server and on a client. This is not terribly exciting anymore. All of us do this. You know, hands up who builds web servers and client systems and stuff. Yeah, pretty much everyone in the world now does this. But it's worth kind of reminding ourselves why this is a good idea. So the nice thing about client server, the server is where you have all your storage, your behavior, your security, you know, all the stuff which is kind of really, really important to the entire system. And the client is where you can do the stuff that matters to one user. You can do your presentation, your user experience, your user interaction. The best thing about client server, if you make a change, you don't need to send that change to all of your clients. You know, I'm old enough to remember when software got pressed onto CD-ROMs and you had to put them in an envelope and post them. And so if you found a bug, you'd be like, come on, order of 50,000 blank CDs. We need to send out a patch for this. Client server, we don't do that. You can fix the server and you can serve multiple clients from the same server, so all your clients are always getting the latest version of your software. The second constraint of REST is a thing called stateless. Now, state is the idea, there's a lot of confusion around this. The simplest example, has anyone done stuff in .NET or ASP or PHP using session variables? Because I have, yeah. Session's not stateful. Session is that thing done wrong. The idea of stateless is that, so if you get this wrong, your client connects to your server and the server goes, okay, I'm going to allocate some storage for you and store some state. Then another client connects and the server goes, okay, allocate some state for you. And another client connects, and another one, and another one, and another one, and another one, and another. So suddenly the server is full. It can't handle any more connections, no more clients. Then one of these clients disconnects, you know, they go away. And the server doesn't know they've done this. So we're hanging on to this chunk of memory on our server, which we're paying for. You know, we're paying money for this processing power, and no one's using it. And then, because the server is full, we have to spin up another server. And then one of our clients gets redirected from the old server to the new one, and their request fails because the state that they're expecting to be there is gone. Now, this doesn't mean you can't have storage. You can have databases, you can have you know, document stores, S3 buckets, cloud file shares. What it means is that the server that runs the code shouldn't care at all about who the client connecting is. No state. It shouldn't matter which server the client talked to last time. It shouldn't matter which server they're going to talk to next time. The third constraint is around caching. Now, caching is the idea the server hosts some resource. Maybe it's static, maybe it's the result of a calculation or a report. The client requests the resource, the server sends it back, the client gets a copy of it. If the resource doesn't change very often, the client can just keep that copy. Next time it needs it, it can just run the copy that it already has locally. So you don't need to make another network hop. Now, this is a really good idea because the server over here, this is yours, you're paying to run that. The client is someone else is paying for that. So if you can offload processing and storage onto the client, other people help make your system go faster. Caching leads us to the fourth constraint, which is the idea of layered systems, the idea that it shouldn't matter. So we've got this client-server architecture. We want to be able to put layers in between those things. We want to put a proxy in between the client and the server, for example, and then that proxy can do more clever things. So the first client requests a resource. The response gets sent back. The second client requests the resource, and the proxy goes, hang on, I don't need to go back to the server. I've got a copy of that. That's good. Sends that back to the client. So again, we're using the layers in the architecture to reduce the load that's running on our server, our system. We can also use this to decompose our solution into multiple layers. So we can have a client that connects to a caching proxy. The caching proxy can connect to a security appliance. So we can do things like validate credentials and terminate certificates and, you know, secure sockets at this layer here. That can then connect to a load balancer. Behind the load balancer, we can have as many servers as we like. The point is the client doesn't know. We haven't had to change this system at all to introduce all of this extra power and flexibility into our architecture because we're building it in layers. So the client doesn't care, and the server doesn't care either. The server thinks that this thing is a client. Doesn't care what the client is, doesn't care what the client does. The fifth constraint is something called a uniform interface. Now, what this basically identifies is 4 constraints about how your clients and your servers communicate. The first of them is the identification of resources. This is the idea that anything, if it's a document or a service, a resource, something that is useful, exists on the web and there is an address that you can use to identify it. These services and resources have representations. So we have a concept of, say, a customer. If representation, what do you want? Do you want the customer as JSON? Do you want that customer as an Excel spreadsheet? Do you want the customer as XML? Do you want the customer as a bitmap because you want a photograph of what they look like? It's this whole idea of representing the objects in your domain using models and representations. Self-descriptive messages. This one's important when you start debugging things because you want to be able to read the network traffic and see what it actually does. So HTTP is built on this idea: get, put, post, delete. The message tells you what it is that it's going to do. If you've ever seen a website where you have like a blog management system, got all these articles and there's a link for delete, and when you click it, it does a get that deletes a blog post, and then Google comes along and it crawls the page and all your blog posts get deleted because it's getting them all. That's wrong, because get shouldn't delete something. Delete should delete something. Get shouldn't delete because that's not what it's supposed to do. And then something called hypermedia as the engine of application state, which we're going to talk about for most of the rest of the talk today. The sixth constraint was a thing called code on demand. So this is the idea that your client can request some resource from the server, and the server sends it back, and that resource includes code. And then the client can disconnect, it can go away, and it can actually run that code later. So you can get clients to do things that they weren't originally designed to do, Gmail is a brilliant example of this. A web browser, Google Chrome, is not an email client, but most people I know, including me, read their email using a web browser because the web browser can run code on demand. The code on demand is JavaScript, and JavaScript is what gives it the behavior that lets Gmail behave like a mail interface instead of a web interface. So these are the constraints that Roy Fielding originally outlined and basically says, if your system follows these rules, it's a RESTful system. Now, as I said at the beginning, that doesn't mean that it's a good system. It doesn't mean it's the right answer for your problem. Maybe you've just spent 6 months building a RESTful system that you didn't need to build, and now you've run out of funding. It also, if your system's not RESTful, it might still be the right answer. It might be the right solution for your company, for your users. But if you're going to say, we have a RESTful system, these are the rules you need to play by. Now, there's one caveat here. Code on demand is optional. You don't have to do this part. This part is optional. It's discretionary. The rest, if you're going to be RESTful, that's what you have to do. If not, fine. Do your own thing. But it's important that, as engineers, we agree what these terms mean so we can have meaningful conversation about how we are going to integrate and develop solutions together. Okay, so for the rest of the talk, we're going to look at some common patterns, we're going to look at some problems, and we're going to look at ways that we can use REST to solve those problems. And we're going to do it by building a social network, because social networks are cool, and we're going to do it by building a social network for superheroes, because superheroes are also cool. And there's lots of money in it, and we all want to get rich. So we're going to build a thing called Hero Book, which is like Facebook for comic book superheroes. And we're not going to build any front-end stuff. We're just going to build an API platform. And then other people can build mobile apps and websites that plug into our system and do all the hard work for us, okay? So we're going to build an API. And the first thing we are going to do is we are going to build this, our root endpoint, which is get /. And that's just going to give you back a thing that says, welcome to Hero Book. We get that, we're deployed, we can test it, we have a running system. Doesn't really do anything. So now we need profiles, because to do a social network, you have to have profiles. So we're going to put in one record. We're going to put in Iron Man, Tony Stark, and we're going to say, okay, if you go to our API and you get /profiles, we are going to give you back some JSON. We're going to give you this application JSON thing, which is an array, which has a user, and a little JSON document describing each of those users. And then we're going to implement support for adding people to the system, because we want to attract new users. So we are going to implement post. So we go to post /profiles, and you give it a little snippet of JSON. So you need a username, Black Widow, and a name, Natasha Romanova. And it's going to return 201 created. And it's going to say, we've made a resource for you. It's over here. This is the identifier for that resource. This is the representation. And then, we're going to go and have a beer and go home for the weekend. And we're going to come back in on Monday morning, and discover that this has gone viral. It was on Reddit and Facebook and Hacker News and 4chan. It's gone absolutely everywhere. And loads and loads and loads of superheroes have signed up. Like all the heroes in the entire Marvel and DC expanded universe have all joined our system over the weekend. And we have a bit of a problem now because there are 2 million users. And we're sitting there thinking, you know, what are we going to do with this? And then the phone rings. And one of our network engineers says, hey, your API is using all our bandwidth. And then someone says, your stupid API is overloading our database. Except, you know, we're in Belarus at the moment. So what actually happens, the phone rings, and the engineer says, Vaš API zabil ves naš kanali. And then the database guy rings, and he says, Vaš idiotski API progrožajt naš dastanik. We have a problem. How are we going to fix the problem? So a lot of people are thinking, well, it's okay, we'll just break it down. We got 2 million records. We'll break it down into pages. Page 1, page 2, page 3, you know, and we'll build a system that does this. 4, 5. And when we get to no content, we're done, you know, finished. Now this will work. This is, like I said, a perfectly good solution to the problem. But if you want to be RESTful, this is not the right way to solve that problem. The reason it's not RESTful is that there's nothing here that tells us we can do it. There's no information in this resource. There's no hypermedia. Now, when we talk about hypermedia as the engine of application state, what it means, state is where am I and where can I go? What are the operations that are available to me from here? And at this point, that 2, 3, 4, 5, you can't work that out from the resource. You'd need to read the manual or phone us for help or, you know, get some assistance with it. It's not RESTful. What we need to do is to implement this using hypermedia as our engine of application state. So we're going to take that basic resource and we're going to extend it. First of all, our content type here is no longer just application JSON. It's application HAL plus JSON. And we're going to decorate it. We're going to add a collection in here called links. And inside that links thing, we are going to say, all right, self, this is where you are. These are the operations that are available. There is a next and there is a last set of resources here. And we're going to give you hrefs, identifiers that you can use to go and, you know, execute those operations. And then to make it a bit easier to implement with this, we're going to extend it a little bit more, and we're going to say, okay, so you've gone get profiles. We've given you back 5 things. You're at index 0. There are 223 things in this collection, and here 1, 2, 3, 4, 5 are the resources, the payload for this page of resources. And over here, self, next, last. This is where you can go from here. So that's the pattern. Now we're going to look at how you can actually implement that using .NET and Web API. So before we go any further, I am using a really cool thing here called FireCode. FireCode is a programming typeface that uses Unicode ligatures. So when you type equals equals, you get this thing. And when you type not equals, you get this thing. So if you see some weird glyphs and things you don't recognize in the screenshots and the walkthroughs, it's not magic. It's just a font. And it's an open source font. It's on Tonsky/FireCode. You can go and download it. So this is a little kind of GUI Explorer tool that I've built. You can get the code to this on the GitHub repo that I linked to. What it allows us to do is to explore a Hypermedia API as though it was a website. So we can actually explore and click around interactively on that API. So we're going to hit our /profiles. And we're going to hit go, and it's going to do a request, and we're going to get back a response. And as you can see, what we've got here, that's the URL we've requested. 200 success is pretty good. We've got this array here, and as you can see from how far we're scrolling, this is the whole thing. This is all 2 million users in one massive, great big array, and this is why all our network team and everyone are getting upset. We need to fix this. So there's a couple of things. First of all, we need to give ourselves a way of adding some more stuff to this. So we're going to go over now. This is ASP.NET Web API I'm using in the first demo here. We're going to jump into the backend system. Now all we've got here, we've got a database, our demo database here. And in this get method, we're saying, okay, db.listProfiles, that's going to give us all the profiles, and then return them. That's it. Really, really simple. What we're going to do now is to break that down a little bit. So instead of just returning profiles, we're going to create a new anonymous object. And inside that anonymous object, we're going to put a field called items. And we're going to say items is profiles. It's the thing we just got out of the database. And then we are going to return that result. And now, when we build the solution and flip back over to our API client, what we'll see is that instead of this massive, great big JavaScript array, when we refresh the resource, we're going to get a JSON object with a really big array inside it. So we haven't really solved the problem yet, but what we've done is to give ourselves some room to work. We've changed the format that's coming back. So the next thing we need to do is to start breaking this down a little bit. So let's jump back over to the other system. Now, we want to break this down. We don't want to bring back all of the records in one response. So we're going to decide, okay, we're going to break this down in pages. We're going to do 10 results per page. So we'll set up a variable to manage that. Now, we're assuming that our database here is smart enough that it supports link. So when we say take, skip, all of these .NET link operations, it's going to translate those down into data and do the right thing to manage the load. Entity Framework will do this. Link2 and Hibernate will do this. Most ORMs will do this. Your own providers will do this if you've written them to support it, but it's quite a nice pattern. So by putting that in, we've now, when we go to /profiles, we only get the first 10. So, you know, we fixed the problem. We're not overloading, saturating the network, and crippling the database anymore. Next thing we need to do is to allow you to paginate it. So we're going to go in and we're going to pass in an index and a count. What page are you on? And we're just going to skip that many results when we go into the backend code and take the result. Jump back over into the code. Now, okay. Hang on. Okay. Then we need to add some hyperlinks to this. So what we're going to do, we've got this anonymous object, this new object. Because it's an anonymous type, we can put any fields we like in it. We don't need to build a sort of strong type system to represent our hypermedia. So we can just put in a links equals a new thing with a next, which is a new thing, which has an href, which gives us the page that we're looking at. So by using anonymous types, what we're doing is writing .NET here that looks very, very similar to the JSON that we want to come out the other side when our serialization is done. We're going to run that through the compiler, jump back over to the client system, have a look at how it works. And so you can see now, we've got this hypermedia, these state transitions are now baked into the resource representation that's coming back. Okay, final thing we need to do on this one. We've got next. Now we just need to manage the fact that we're going forward, we're going back, we can move around through the result set. This is an extension method that you'll find in the GitHub repo. It's just called paginate. What it does is it takes a path, an index, a count, and a total, and it will generate the links for you that need to be plugged into that hypermedia resource. So we've got a links.first will always take you to the beginning, final always takes you to the end, and then we've got if index is greater than 0, if we're somewhere in the collection, then we have one to go backwards, and if we're before the end of the collection, we have one to go forwards. That will return the links, and then we can just jump over here, we can plug that in directly. So we have a method on the database tells us the total number of profiles we've got, so we can use that in our calculations. Plug in the paginate method, give it the path that we're paging backwards and forwards through. And then when we build and run this, what it's going to give us is a completely paginated result set, where on any page of that set of results, it's going to show us what are the transitions that are available from where we are here. First, final, last, next. And if we jump right to the beginning of the collection, you'll see that we can't go back any further because that last element is now going to disappear. it's quite a simple example, but it demonstrates the idea as someone is working with your resources, there are going to be operations that are available from here which aren't always available. We want to manage the availability of those resources using Hypermedia. We want Hypermedia to be the thing that manages your state and communicates to your clients what it is that you can do from any sort of given point on an API. Okay, so social network, brilliant. We've got profiles. We've got lots of people. We've solved the problem of our database being overloaded. Now we're going to add friends, because it's a social network, which means people want to make friends with other people. So we have the profiles collection here, and we're going to say, okay, so username is Iron Man, name's Tony Stark, friends here, this is a JSON array of all the people who Tony Stark is friends with. And he's a popular guy. He's got 500 friends in here. And now all those friends want to know what Iron Man has been doing. So we're going to add updates. So Tony Stark is going to say, hey, I'm building a new Iron Man suit, and it's going to have a selfie stick on it. And then he says, selfie stick broke off. Oh, well, you know, back to the drawing board. Got to run this one again. So he's got all these updates, and he's got all these friends. The problem is, all of these friends are also posting updates. And all of the friends have also got friends. And all of the friends' friends are also posting updates. And now we have a problem, which I think they call big data, which is where you have too much JSON for one PowerPoint slide. Is that big data? So, the phone rings. And you can guess what's going to happen. It's the same team again. Vaš API zabil naš kanali apiat. And the database engineer, vaš API perogržat vaš dadik apiat. Ja gavaril nam nužno bila dešacia PHP. Our database guy's a big PHP fan. And he thinks all this .NET REST stuff is nonsense and we're wasting time. So we got to solve the problem because we don't want to go back to doing PHP. Do we? I assume we don't. No, good. So we're going to break this down. We're going to say, okay, we have a links collection here. So instead of everything coming back in line, we're going to break all of these sub-resources out into things that we can get to via Hypermedia. So we have self, we have friends, we have photos, we have updates. All of the different elements on this network. Now this looks pretty simple, yeah? Except we launch this, put this in production, and this happens. Someone goes, get profiles Iron Man. Okay, they go, ooh, look, Iron Man has friends. I'll get those. Okay. Iron Man has updates. I'll get those. Okay. Iron Man has photos. I'll get those. Okay. Iron Man, ooh, photo 1, 2, 3, 4. Get that one. Get that one. Get the comments. Get photo 1, 2, 3, 5. Get the comments on that one. Get the comments on that one. Get the comments on that one. And the phone rings again. And it's one of the API developers or the client application developers. And they say to us, ja должен instaliat 50 wizów w API prosto, чтобы видать одну web-страницу. I got to make 50 API calls just to draw one web page. What's going on here? And our network guy phones again, and he's still not happy. Nasz web server upal z того, что AS logi заполнили drive C. У нас никогда не было таких проблем с PHP. This is bad. So how are we going to fix this? Now, one of the things that you'll come to sort of, it took me a long time to come up with this particular pattern. This is something called resource expansion. Now, if you remember one thing from this talk that you go away and you put into Google when you get back to your office and you start trying to do this, remember that, resource expansion. Because what we are going to do is we're going to give our clients a way to say, I would like to get Iron Man, but please, I know that I'm drawing photographs, so let me expand those in line. Send back more than one thing. So we're going to say profiles Iron Man, expand equals updates. So we've got links, we've got the username, we've got the name. We're going to add another element to our JSON here, which is called embedded. This, by the way, the embedded and the links, this is a dialect called HAL, Hypermedia Application Language. There's about half a dozen different ways of doing Hypermedia in JSON. If you're doing this stuff for real, it's worth having a look around and looking at some of the others. I'm using HAL because it's quite easy to read and it works well on the sort of slide format. So we're going to add embedded, and in there we are going to put updates, working on an Iron Man suit, update, selfie stick broke. So now, you know, we can do a single request and we can get back all of this data with one request, one response. Okay, so let's have a look at how we do this in code. Now, I'm going to switch here. Some of the patterns I'm showing you will work in, these kind of patterns. REST works in any language. REST works on any system. You can do REST in PHP if you really, really want to. I wouldn't, because I'm a .NET developer. The first example I showed you, I was using Web API. For this one, I'm using a .NET framework called Nancy, which is a really nice, lightweight, dynamic, opinionated framework for building HTTP applications. So the code will look a little bit different. If you're interested, as I said, it's all on GitHub. Download it. Hit F5. It should run. You can play around, see what it does. So now we're going to go and hit profile/Ironman, and we're going to press go, and it's going to come back with this, very, very simple resource representation. How do we expand this? So this very quick sort of whistle-stop tour, the way that a Nancy module works is we have this dictionary of roots, and every root takes an argument or a collection of arguments and maps them onto a method. So we have this method here called getProfile. It takes a username, does db.loadProfile, so it's getting one profile out of the database, and it's going to give that profile back. Really, really simple. What we want to do is to extend that by saying profile.links. So we're going to jump in here, and we're going to go profile_links, and it's going to blow up. The compiler is going to complain because it says, your profile doesn't have a links property on it. You can't do that. Now, what we don't want to do is go to the database person who's already upset with us and say, we need to add a whole bunch more things to our entity framework objects, our domain model objects. We need a way that we can break out of the constraints of .NET's type system so we can do some hypermedia and dynamic stuff with it. Now, there is a very, very cool trick you can do in .NET, which I didn't invent. I got this off Stack Overflow. .NET 4 introduced a thing called dynamic types, which is basically an object that has no type checking. So you can stick any fields, any properties, any methods you want onto it. And because of reflection, we can actually take any object we've got and turn it into a dynamic object which has the same structure. So this thing here, this public static toDynamic method, takes any object, and what it's going to do, it's going to spin up a new Expando object. This is the kind of fundamental basis of doing dynamic typing in C#. We're going to turn that, or we're going to coerce that into being a dictionary. We are then going to go, okay, let's go through all the properties using reflection. So get the type of the object, get the properties of that type, and then for each property, get the name and the value, put them in the dictionary, and return it as a dynamic. So what it means is that back in our front-end code over here, we can say profile equals loadProfile.toDynamic. This thing is now wide open. We can bolt stuff onto it anywhere we like. So we can say profile links equals this, self equals this, photos equals this. And the thing that I really like about this approach is this is the only place this happens. Dynamic typing allows you to do some powerful things, but also it takes away some of the safeguards of compiler, compile time type checking and stuff. By doing this, it's dangerous, but all we're going to do with this profile object is we're going to turn it into JSON and then we're going to throw it away. And JSON has no typing anyway, because at the end of the day, JSON is just a string, and the string is going over the internet to somebody else, and we don't really have any control over what our API consumers, the clients, are doing with it. So we can do that. We can break out the constraints of the type system. We can jump back over to our front-end code. We can hit go on that. And without having to write, a strongly typed, I've seen people do things where they're like, okay, I need a JSON resource abstract base class, and then I need a links property on that. And there's a case for working that way. That's not the way that I like working when we're solving these kinds of problems, because the controller is where we manage the thing. We've got a database over here. We've got the wild, wild web over there where anything goes and JSON is king. And we've got this layer between them, which is our controller. That's where we can do our thing. That's where we can do our API development stuff. And this gives us quite a nice pattern to go and implement this kind of hypermedia stuff. Okay, so, ding. I'm just trying to remember what this bit of code is. Resource expansion, that's right. So all we're going to do now is we're going to pass in on that query string very, very simple. We're going to say, okay, request.query. In Nancy, this is dynamic, so we coerce it to a string. And we're just going to say, if expand is not equal to null, and if expand contains friends, then all we're going to do is we're going to hit the getFriends method on our data access layer, and we're going to paste that in line. Hang on. Sorry, bear with me 1 second. Okay. So yeah, we're going to capture the query string. We're going to look for an expand parameter that's been passed in there. We're going to extract that and look at what comes back on it. Now, obviously, there's all kinds of ways that you can manage this. You can cache things in memory. You can have static resources that are compiled into your application. You can have stuff coming out of the database. You can even use expansion to do other HTTP calls to resources you know are hosted locally on your own network. So you're the one making all of the multiple requests. And so all we're going to say here, if expand contains friends, then let's add an object called profile.embedded. So we've used the two dynamic here to break out the type system. We've added links. We've added embedded. We've added expand equals friends. We're going to hit go on that. And now when we add the expansion parameter to it, what you should see is that that stuff has actually been expanded in line. Okay. And there we go. So we can see in there that Iron Man's friends on this particular system are Aquaman and Batman, and I think Hanselman was in there as well. Okay, let's move on. Last thing we're going to look at today is how you can do updates, selective updates to resources that are hosted on your system. So we've got a social network. We need to make some money. The way we make money is we take all our users' data and we sell it, because that's how the internet works. And we don't have good enough data to sell yet. We need all sorts of weird, kind of stalky detail about our customers. So we're going to add, okay, we need you to enter your height. How tall are you? How much do you weigh? Where do you live? What's your location? What's your status? Where are you from? What's your hometown? What's your email address? What's your website address? And we're going to add a last modified field so we can track how fresh this data is, because advertisers love buying fresh data. So we're going to put all that stuff in. And then Iron Man, who's wearing his new Iron Man Apple Watch, is going to try and do an update because he's on his way back from a mission. So he's like, okay, I'm going to do a put here. I'm going to update my profile, application JSON, and I'm going to update the status with, I just got back from saving the world again. And he's going to get back a 409 conflict. Now, the reason for this is that over here, we've got his location. And he's updating it while he's flying across the Atlantic in his rocket-powered Iron Man suit. So by the time he's finished tapping out the status update, his location's out of date. And all that our server can do is it can go, the thing you've sent us doesn't match your last state of this resource. There's a conflict. We don't want you to overwrite something, so we're just going to reject your update. Now, this is a problem, and you know it's a problem because the phone is going to ring. And what's going to happen is you're going to get one person coming in and saying, Почему мне приходится засовывать путь за профиль лишь для того, чтобы обновить координаты? And the next one is going to say, is one of your app developers going, Мой обновление происходит с ошибкой 409 конфликт. Помогите. Help. You know. How do we fix this? There's a couple of ways we can do it. One of them is we can break it down into just sending the fields we care about. Now, this is quite a common pattern. It works. A lot of different people have used it. It's not really RESTful, because what we're doing here, what we're really saying is I want you to replace this entire resource here with this. I have seen applications that just say we're going to ignore anything that isn't specified. You actually need to set them to null if you want them to be deleted. So this is a pattern that works. I wouldn't recommend doing this. And what the server's going to do is it's going to say, yeah, 204, no content. I did what you asked for, but there's no meaningful reply I can give you. There's another thing you can do here, which is you can say, okay, I'm going to put profiles Iron Man status. I'm actually going to break out that one detail into a resource in its own right that you can get and you can put. Now, This works, it's pure, it's RESTful, it's clean, it's easy to understand. The problem is your controller code ends up very, very big because every single detail ends up having one of these routes to address it. So the last thing that we're going to look at today is a thing called HTTP patch. Now, the patch method it's in the HTTP specification, and it says patch describes a set of changes described in a request that should be applied to a resource. The set of changes is in a format called a patch document. And then it gives us this wonderful example where it just says description of changes. There's no standard for how you describe a patch. There's no standard for describing the change you're going to make. So one thing you could do if you've got a Linux machine or something is you can download the profile file and you can just run it through diff and you can get a patch file at the other side, and then we could build an endpoint on our server that takes patch files. So this is the resource, this is the verb, that's the self-descriptive message. This is the content type of the thing we're sending in. That's the status we're sending back, and that's the one we're updating. And the server's going to go, okay, I know what that means. There's a slightly better way of doing it. There is a thing called JSON patch, which is a way of describing operations. And what this does is it gives us a list of things to do. We can modify things, we can test things, we can update things. So we're going to say, okay, here is an array of instructions. First of all, I want you to get a /status on this resource here and replace it with finished saving the world, I need a drink. Then we want you to do a move operation, and we want you to find the resource that's at this path here and move it here. Because the Incredible Hulk has just saved Tony Stark's skin again, and he wants to make him his best friend by putting him at the top of that list. So one of the fun questions that I have in my REST workshops, how would you reorder a playlist using REST? And people are like, just put the whole new list and stuff. So you can do move operations where you take something from one path and you put it using a different indexing strategy. And you get back 200 OK. Or, because the specification is wide open, we could invent a completely 100% standards compliant thing. So we are going to patch conferences .NET Belarus, .NET BY. We're going to use the content type of an epic selfie image. Description of changes. Let's make .NET BY the best conference in the world. And the server is just going to say, 202, accepted. Challenge accepted? Why not? We have a few minutes for questions. Thank you very much. And I apologize for my dreadful Russian. I had to try.
Thank you for the talk, and thank you for bringing heroes to Minsk, first of all. I actually have two questions. Yeah. The first one is, could you provide a couple of typical use cases where you would go for Hypermedia as the engineer of the application state, and when you would not? Like, imagine you just get the new project, whether to use it or not. So this is the first question. And the second, maybe just share your opinion on the Open API initiative, if you know it.
Okay. So the first question is, under what circumstances would I consider using the Hypermedia as the engine of application state approach? As I said at the beginning, I tend to use that if it's something I think is going to last for a long time. So my team and I back in London have just started building, earlier this year, we've been working on it for about 6 months. It's an API over a set of data that we know is not going to go anywhere. It's something that we're building as a platform for a 5-year development roadmap. And so what we've done there is we've used Hypermedia. The nice thing about Hypermedia is you can kind of build an API, and if you need to move like one bit of it onto a different server or a different platform or even a different hosting engine, different environment later, you can, because as long as all your clients are following those Hypermedia links, it doesn't matter if one of them suddenly links to a different server or a different domain. You've given yourself this ability to move resources around on your own platform. The other nice thing that we sort of discovered almost as a side effect is for integration testing. What you can do is you can write a test. So you deploy your API, and then you say, okay, go to the root, the endpoint, and find links, and look in links and find profiles. And then look in profiles and find Iron Man. Follow that. And then when you get that response back, verify that it matches this format or it passes this assertion, this test. So it gives you a way of writing integration tests that actually use Hypermedia to make your tests resilient. So even if you do move things around, the test will still validate that the thing works. As for your second question about OpenAPI, so OpenAPI is, I don't know it terribly well. This is the thing that emerged from Swagger and so I've played around with Swagger and the idea of documenting APIs. There has to be somewhere in your system where you enforce your decisions, what we call the source of truth. Now, that can be your code. I've written APIs before using platforms like Service Stack, which is very, very opinionated and has lots of boilerplate. So Service Stack, for every method, you have a request model, you have a service model, you have a response model. Now, because you've put all that richness in the type system, you can generate things like documentation and specifications directly from your code. Now, the approach we just looked at here, it's dynamic, it's using Nancy. You can't actually learn anything from the compiler about what your API is doing, because all your API does is like, well, I do dynamics. You work it out. Anything can happen at runtime with dynamics. So for us, the integration testing is the source of truth. That's where we encode the decisions. Now, something I think is interesting, because Swagger and OpenAPI give you another way of doing this. You write a YAML file or a JSON file, say, this is my API design. This is what it looks like. And then you can use that to generate code. So there's a thing that generates Nancy from OpenAPI files. There's a thing for Amazon that will set up an API gateway from OpenAPI files. Problem is you have to maintain the OpenAPI file. And I don't like writing YAML by hand, and the online tools that I've used for it kind of tend to crash and take all your work with you because they found a syntax error. Now, what I'm interested in, I think OpenAPI is a really good idea. What I'd like is a way of using that as the input to a set of integration tests. So YAML is your source, OpenAPI is your source of truth. Your tests are generated from that, so you don't have to write your tests by hand. So that's where you move the effort. But I also think the tooling around it has to improve, because at the moment I'm not aware. I've tried maybe half a dozen different online and offline things, and I'm not aware of anything for editing OpenAPI files that I haven't found frustrating. So I think it's a brilliant idea, and maybe give it another couple of months, and it'll be seriously worth looking at. Thank you.
Thank you again. My question about JSON Pure API.
Yeah.
As we know, the RESTful API have so many codes, and sometimes we don't fully understand what they mean. For example, the code 417, if I don't mistake. And what do you think about Open Pure API in general, and about Open Pure API as some kind of an evolution of RESTful API?
So Open Pure API?
JSON Pure API.
JSON Pure API. It's not something that I know terribly well. I agree with you about HTTP codes being confusing. There are lots of them. My team have had long arguments about whether we should be returning a bad request or conflict or something from a particular one. But I wouldn't say I knew enough about it to give a very useful answer. Sorry.
Sorry, no. Yeah, okay. Yeah, no time. Hi.
Hey.
What do you think about approach to build different APIs for web and mobile, for different type of clients? What do you think about this approach?
There's a pattern that's worth looking up. So the question is, what do you think about building different APIs for web and mobile, like different APIs for different clients? There's a pattern that is getting a lot of attention at the moment called BFF, backends for frontends. And basically the idea is you have your service APIs, your microservices or your domain services. But then if you have, say, you're building an Android mobile application that needs to do customers and billing and authentication, you build a little tiny API that exposes those three things by proxying the calls onto your different backend services. So you're providing an API that's optimized for a particular client, but you're not solving the same problem twice. All your authentication is still handled by your authentication service. All of your customer billing information is still coming from the billing service. So, and that's, I think, a pattern that's very, very nice, because it's very easy now with things like API gateway and serverless hosting, Lambda functions and things, to have an API that just proxies calls onto other things and maps them back again. So I think there's a lot to be said for if you have a team working on a mobile application, you want to make their life easy, you want them to do good work and go home happy. You can do a lot of that by tailoring a certain API, a set of endpoints to their requirements, but you don't need to actually build your whole API around that. You can use the BFF pattern in front of it to deliver the same benefits without so much work. Does that answer the question? Cool. Okay, I'm going to take one more and then break for coffee, but I'm here all day, so
Hi.
who feels lucky? There you go. You got a microphone. What's the question?
So, have you experience of splitting monoliths to microservices, for example, RESTful microservice, and was it successful or not?
I don't know. I've been doing it for 5 years. I'm still doing it. Give me another 5 years, maybe. No, I work on a very, very monolithic code base. That it's monolithic because it's coupled to a database that's coupled to a desktop application that we don't have source code for. So we can't change the database, otherwise the application breaks. So we've done a lot of very interesting work about taking elements of that and putting them into microservices. It's the interesting thing, the definition of a microservice is something that has its own storage and its own endpoints and its own behavior. That's hard because when you have a monolithic system, the other components need to be able to cope when a piece of their storage is removed. And that's the biggest challenge we found, is it's easy to build a standalone service. It's not easy to to evolve the monolith so that it'll keep running. So, I'm still working on it, still enjoying it. It's still a nice way to work, but I wouldn't say I was finished yet. So it might still all go wrong. But come back in 5 years and we'll talk. Okay. Thank you very much. I'm around all day. Come and grab me if you have questions. Spasibo.